Right. We have several people decided to work on this tutorial earlier today, so that's why they are not here, because they already finished the most part of it. Because everything is posted online, so that makes sense. And you can tell it should be pretty easy, since they don't even need a lecture from me. They can finish everything. It's very straightforward. It's an extension of the lab 1. So lab 1 we did resistors. But here we will do a schematic first and then do the layout. So several ideas I want to talk about. That's very important ideas regarding VLSI design. Okay, similar to embedded systems and modules, like I already talked about for several times. You can see for resistor string, it really doesn't require a lot of efforts to lay it out. But for the schematic, it's just trying to show you the idea or the standard workflow that we usually follow. Okay. So see here, you connected all these resistors in the resistor string, but some of them are pretty clean, looks good, but some of them looks just resistors everywhere. Okay, they are basically repeating modules, right? And if you create individual resistors and connect it in this way, maybe your hands didn't shake when you are making these connections, but probably it's gonna shake, during the connection of these rest resistors, and it looks not really well organized. So the way usually we follow, or the standard workflow we usually follow, is find a repeating module and make that module into an icon, right? So we can repeat that part of the unit by dragging that icon into your new schematic to form a new schematic from it. What are the benefits of doing this? Yeah, that's great. And also for error checking as well. Imagine that if you have 20 resistors, it's fine. You do a DRC check, boom, you'll see like 5 errors. Not a big deal, just find those errors and check it. What if you have a billion resistors? You want to manually lay out every single resistor over there, and you do a DRC check, shows you like 1 million errors. What's the next step? Locate every single error and fix it manually? No. So if you have this repeating module, okay, you do a DRC check within that module first, so know that module works. Then you'll start building a bigger circuit using that module, which you know it works. So eventually when you see errors, it's going to be in the upper level circuit instead of the sub module, because you know the sub module works. So you can do DRC checks at different layers. That'll be way easier. You'll see that sort of benefits a lot in the future when you're laying out bigger circuits. Very important idea here. So for this resistor string, we don't really have some sort of like functional modules. It's basically just resistors, but you can definitely find that. Okay, so these 3 resistors are getting repeated. So let's make these 3 resistors into one icon, like this. So in order to make an icon out of it, so what we need to do is create a ports. So as you can see, this 3 resistor unit definitely had 3 sort of ports, even though this is not a port. But if you consider this whole thing is icon, this part here is definitely a port. It's being used as a port since you need it to connect it to a next module, right? So it's a port. In that case, I need a port here, and you click the port, the edge of the port, and do a control what? Control E, right? Export. So control E. So you can put a port name over here, and here. So this is going to be the repeating module you can use, and make it into icon. Make it into icon. And so the icon, after you create the icon view, the icon will directly show up in your schematic view, like this. So when you want to modify the icon views labels or text size, the font size, or anything else, where should you add that details of the icon? Directly in the schematic view or somewhere else? In the icon view, remember. So you create the icon. So electric view side is nicely showing this icon view directly in the schematic view, which is just for your reference, which is a great feature, I think. I like it. But the thing is, you don't want to directly edit the icon's details within that schematic view. It's just generating an icon here. It's just showing you like a reference, but not telling anything else. Don't touch it. Okay? Go to the icon view. It's going to generate in the drop-down menu. There will be a schematic view, icon view. So double-click icon view and get into the icon view and edit the details. You'll change the labels, the direction of the labels, size of the font, anything. Okay, even the size of the box.
I'm struggling changing the size of font.
Is that Control I?
Yeah.
Yeah, there should be. I'll look into that later. Okay, it should be Control I, and there should be a menu in the window. If it doesn't, I'll take a look at it. It's been 2 years. All right. Do a DRC check in your report. Every single step, every single sub module, every single step, do a DRC check. It's just F5. Okay, don't wait until it's too late. So do a DRC check before moving forward. So know it works. Okay, so you can repeatedly using it. And show the DRC check window in your report to receive credits. And you can see this one, schematic view, which is the real R2R DRC, R2R ladder DRC. But I dragged that icon in here. Which icon? The 3 resistor icon, right? So I open up this new schematic first, and I drag it for 1, 2, 3, blah blah, how many times? Okay, I drag it here and to form a new schematic. This is, keep in mind, this is still a schematic view, but it's a new schematic view. Okay, what's next? I generated the ports for this new schematic view, and I create another icon from it. Okay, think about this for one more time. It's going to be the convention for this sort of design strategy in the future. I know the 3 resistor module works past the DRC. I reuse it, and I just use physical wires to make the connections. I know the physical wires are very unlikely having any issues. Okay? And I know these 3 resistor strings modules are working, so I put them together, I connect them with the wires, so I know it's going to work. I make the connections, I do a DRC, boom, it works. DRC error clean. And then I generate another module out of it, so I know this is a DAC chip, it's a DAC chip that I can use for millions of times. I know everything works inside. Okay, so if I find issue of this icon, I just need to go back to that icon and fix that icon's problem. Then all these icons issues will be solved. If I have millions of these icons being used, I don't need to open up every single one. That's the benefit of using sub-modules. And you need another resistor, which is cannot put into any of the 3 resistor modules, right? So it's going to be another individual resistor here. Just to let you know. Do a DRC check, error-free. That's the task 1, 50 points for the lab. Okay? Next, with the sub-cell, so this is the library of the cell. See, R2R sub-cell, library. You see it has 3 colors, the red one, yellow one, blue one for the sub-cell. So the yellow one is schematic, and the blue one is the icon, and the yellow one will be the layout. So right-click and create a new view. The view name is, the view type is layout view, right? So in addition to the 2 schematic icon, you create a layout view as well. right click and generate the new layout view. Okay, so in the layout view, drag and drop a unwell resistor in here and modify the width and length accordingly. And the same thing for the layout. Because your schematic has 3 resistor modules. You want to do the same for your layout. Keep in mind, always, whenever you have billions of transistors, there's an error check called LVS. It's layout versus schematic. Okay? If you organize your schematic in a certain way, you want to organize your layout in that same way. It's checking your ports, checking your sub-modules, checking the values of the components, checking every single thing. So since I generated 3 resistor schematic modules, sub-modules, I need to create 3 resistor layout and put them into icons as well. So in the layout view, I'm going to generate a 3 resistors, 1 10K, 10K, 10K. So the length of the unwell is calculated by the sheet resistance. I believe it's 800 something. So it shows you the calculation here, right? Just follow. So you'll know the length required for the unwells. So these are the unwell materials. One quick question here. What is this square here? Via. What is this one? Metal 1. Okay? Metal 1. What is this green color here? What's the green color? Unwell. Unactive and unselect. It's just putting an N plus into the unwell. The reason for that is unwell is not really highly concentrated, highly doped. It's not highly concentrated, but N plus are. So N plus is a highly concentrated doped material. So usually we use the N plus as an interface between the N material and the metal, because making a better connection or higher conductivity. So you put an N plus node into the unwell material. Sometimes we call it as a tap, well tap, TAP. Well tap, right? It's just a connector, providing a better conductivity. And then you can drill a hole on the top of it, drill a via, and then short it to metal. So it's providing a better connection. Right? And you connect all these unwells with metal 1. So not introducing additional resistance all the trade in between all the resistors, which is not desired. Okay, so only 10K resistors, 3 of them, and make the connections like this. So when you are doing the layout, you want to try to make it as a modular design, so you can further repeat using it. So for example, you look at the ports, the location of the ports. I'm making it very convenient for reconnections. For example, like this one, okay? Like this one. Create a layout view for this schematic, drag, drop the layout into this subcell layout view, all right? So how that works is you create a layout view here, right? For the subcell. Oh, here, sorry. See? R2R subcell. The subcell is created. And then you create an R2R ladders library. Remember we had this? That's R2R ladder library. It's a higher level. So that was a schematic view. So that one has a layout view correspondingly here. Okay? So I generated this new layout view in here, up a higher level, and I open it, and I drag this subcells layout I drag it into this layout view. It's a very similar way of dealing with schematics icons. Makes sense, right? Any questions by far? Easy? Okay, you drag it and looks like this. It doesn't show the details. And there's a way to show the details. You select it and there's a button on the top. You can click and it's going to show the details of the layout. The thing is, on the upper level, whenever you are trying to reuse the layout icon, even though you can click a button to show the details of the layout, but it's not editable. You cannot edit. If you want to edit anything of the layout, you have to go back to the subcells layout to edit all the details. Which makes sense. You don't want to add anything on the top. That's the goal, right? Whenever you see issues, you always want to go back to the subcells to change all the details or errors. So these are just higher level icons of the layouts. And you see, you click this little eye here to make it visible. It's a really good drawing. It's a pretty eye. All right, so you click the eye, it's going to show the details of the layout on the upper level, the higher level. And you can make an array, see? I think that's control something, all right? Then you can make an array of it, like this, see? Directly generate the array instead of you copy and paste. So they will nicely align every single cell in the array. Just following this one. And do a DRC check. Don't forget to do a DRC check. Anytime you add new things to it, do a DRC check. Okay? You can make the connections. These are just metal wires. Very unlikely you are making errors. Just metal wires. Do the connections. Connect everything. And then do a DRC and LVS. Why? Because now you have the R-2R ladder schematic and the layout done. Both are done. So you want to do a layout versus schematic. It's called LVS. In here, in Electric VLSI, I think LVS is called NCC. Just let you guys know. NCC. It's not LVS, but usually it should be called LVS. Here it's called NCC. In Cadence, it's called LVS. Okay, do both DRC and NCC. Okay, to receive the full credit. See here, NCC is doing this. Exports match, topologies match, size not checked. You see? Everything has to match. No errors, no warnings. That's how you receive the full credit, okay, for this. And, all right. The R-2R ladder layout can be used for the simulation as well. So you generate, remember here, the R-2R ladder layout, right? So this layout, okay, this layout. Whenever it's done, you create a new schematic. You keep that ADC in there. Don't worry, don't need to do anything about it. And you replace your schematic version of the R-2R ladder with the layout version of the ladder here, and make connections, and it should show this conversion with the stairs as well. You show this one, then we know that it works. Okay, no errors for the connections. That's another 50 points. Task 2, okay, layout simulation. Any questions on this? No? Yeah, start working on it. Okay, one more thing. I think for people in the embedded system class, at least the Vivado in this lab are able to program your IPG board right now, and also you can start your GVIN from the command line without any issues. Okay, so working. Hopefully tomorrow or the day after, 570 and 602 will work the same way as well. I will see.